Now let's look into the properties of binomial coefficients using the expansion of 1 plus x whole to the power n. So how do you expand 1 plus x whole to the power n? That is nc0 1 to the power n and x to the power 0, which is 1, plus nc1 1 to the power n minus 1 is 1 and x to the power 1, plus nc2 1 raised to the power n minus 2 and x raised to the power 2, plus nc3 1 to the power n minus 3 and x to the power 3, plus so on, plus the last one would be ncn 1 raised to the power 0 and x raised to the power n. So this is the expansion of 1 plus x whole to the power n. Now if we consider nc0 as c0 by just ignoring n, so if there is no number here, it means it's n. Similarly nc1 as c1 and so on, then you get this as, you can simplify this as c0 plus c1x plus c2x square plus c3x cube so on plus cn x to the n. So here the power of the x is whatever the subscript on the c on the combination is, right? So here the x to the power 0 is 1, here x to the power 1, and here x to the power 2, and so on, here x to the power n. So this is the expansion of 1 plus x whole to the power n, and whenever there is no number here, that means it's n. So nc0, nc1, nc2, nc3, and so on. So we can use this expression here and we can deduce a lot of properties for the binomial coefficients, meaning the properties of c0, c1, c2, and so on till cn. So property number one, we can deduce the properties of the binomial coefficients by substituting some values for x. So you can substitute values for x, such as x could be equal to 1 or x could be equal to minus 1 or 2 and so on. So let's see what happens if you substitute x equal to 1. Let's put x equal to 1 in the above equation here. If you put x equal to 1, this becomes 1 plus 1 is 2. So 2 to the n is equal to, and this becomes c0 plus c1, so x is 1, plus c2 times 1 square is 1, c2, plus c3 times 1 cube is 1, so c3, plus so on, plus the one before would be cn minus 1, and the last one is cn, 1 to the power n is 1. So here c0 plus c1 plus c2 plus c3 and so on till cn minus 1 cn is equal to 2 raised to the power n. Remember, these are all nc0, nc1, nc2 and so on. So we just putting in a shortcut form just to make it easier. Now let's put x equal to minus 1 and see what happens. So let's put x equal to minus 1. So if you put x equal to minus 1 in here, this becomes 1 minus 1 is 0. 0 raised to the power n is 0. So 0 is equal to, so this is a constant c0, plus c1 times minus 1 is minus c1. So you get minus c1 here. And minus 1 square is plus 1. So you get plus c2. And the next one is minus 1 whole cube is minus 1. So you get minus c3. And plus so on. The last but one would be cn minus 1 minus 1 raised to the power n minus 1, and the last one would be cn, since x is minus 1 raised to the power n. So one thing to note is when you add all the binomial coefficients by themselves, say C0 plus C1 plus C2 plus C3 so on till Cn, then the answer or the result is 2 raised to the power n. Once you have alternate negatives, say C0 minus C1 plus C2 minus C3 plus C4 minus C5 and so on, then the result is 0. Now let's add this equation here and this equation here. So if you add, first let's add the right hand terms. So you have C0 plus C0 is 2C0 plus, what is C1 minus C1? Both cancel out each other. C2 plus C2 is 2C2 and C3 minus C3 is 0, and the next terms would be plus 2C4 and C5 cancel out and so on. Then this would equal to, on the right hand side it's 2 to the n plus 0 is 2 to the n. So now if you divide both sides with 2, you get C0 plus C2 plus C4 plus so on is 2 to the n by 2 is 2 to the n minus 1. Right? So this is one more equation, right? So the first equation is C0 plus C1 plus C2 plus C3 and so on is 2 to the n, and the second equation is the alternate plus minus is 0, and if you take just the even binomial coefficients, the sum of just even binomial coefficients is 2 to the n minus 1. Now let's see what happens if you subtract this equation or this equation from this equation. Let's do that. So if you subtract this from this, it'll be C0 minus C0 is 0, and then C1 minus of minus C1 is 2C1, and then C2 minus C2 is 0, and C3 minus of minus C3 is plus C3 is plus 2C3, and C4 cancel out because both are positive, and C5 minus C5 is plus 2C5 you get. And if you add, so you get all the odd binomial coefficients. This is equal to, on the right hand side you get, on the left hand side you get 2 to the n minus 0 is 2 to the n. Now if you divide both sides with 2, you get C1 plus C3 plus C5 plus C7 and so on is 2 to the n over 2, which is 2 to the n minus 1. So here you have one more equation, and this equation is the sum of all the odd binomial coefficients. So the sum of all even binomial coefficients is 2 to the n minus 1, and sum of all odd binomial coefficients is also 2 to the n minus 1, and sum of all binomial coefficients is 2 to the n, and sum of alternative positive negative binomial coefficients is 0. Similarly, you can substitute any value of x here, and then you can get some equations in binomial coefficients. That is property number 1. Say if you put x equal to 2, you get 3 to the n on the left hand side, and on the right hand side you get C0 plus 2C1 because x equal to 2, and 2 square is 4 plus 4C2 plus 2 cube is 8 C3 plus so on, and plus 2 to the n Cn. And similarly, if you put minus 2, you get C0 minus 2C1 plus 4C2 minus 8 and so on. So you can play with all the coefficients by putting different numbers for x and adding or subtracting. You can come to different results for the binomial coefficients. So this is property number 1.